let's try to understand why this minimum frame size and maximum frame size conditions are imposed. To understand that, first of all, we should go to our architecture. This is our bus topology. In earlier days, we used to, otherwise people used to implement bus topologies to connect the systems. Now assume that Ethernet is a technology which is defining the communication, right? Now when there is a common medium, then definitely we have to use one protocol called MAC protocol, correct? So Ethernet definitely contains that MAC protocol. What kind of MAC protocol it uses? If you want to know, CSMA CD. Okay, we know that CSMA CD is better than that Aloha protocols, and next one slotted Aloha, right? So we use this CSMA CD, remember it. Now already you know that whenever it is a CSMA CD, then whenever station is sending the data, at the same time it whenever it is sending the data, it can detect the errors, correct? That is a collision detection technique. Now remember one thing, in CSMA CD technique, once data is transmitted, your sender is not going to listen to the station, okay, sorry, listen to the channel. So that's why, see the story. Example, let's say station A is sending one message to station B, and this is the point where exactly B is sending the message. Now there is a collision, correct? So the collision comes like this. When it will reach the station, exactly after 2 into propagation delay, okay, approximately. Now really in CSMA CD, station has to detect the collision, then by that time that station has to send the data. Otherwise what happens? Sir, what happens if we have small data? Then see this story. So A is going to send the data quickly, okay. Now collision is going to come on the way, so collision is coming back. But meanwhile, so the frame transmission is completed at station A, and station A closes listening. Already I told you, only when we have data to send we listen, otherwise we sense. Once data is transferred, we don't require to sense, correct? So that is actually CSMA CD technique, correct? In that really, if in every case collision has to be detected, then what we have to do is, by that time collision comes to our place, still you should be able to send the data. If you don't have enough data, you can't listen to the channel. That's why this is the necessary condition in CSMA CD. Already I explained in CSMA CD protocol, you just refer it again. Now you see this one. So example, let's say the maximum cable length, this is the cable, right, you are using for Ethernet. It's, let's say, 500 meters. Let's try to understand one mathematical calculation. So 500 meters is the cable length, and speed of the light is 2 into 10 to the power of 8 meters per second. Otherwise signal speed is 2 into 10 power 8 meters per second. Now one more thing, let's say bandwidth. So usually, so Ethernets are implemented with 10 Mbps speed, okay. Yes, so the cables can be designed such a way that it supports 10 Mbps, remember it. So standard Ethernet can support 10 Mbps, remember it. This entire story is about 10 Mbps Ethernets or more than that. If you have 10 Mbps Ethernet, so what is the frame transmission time? We will see. So example, let's say if your frame transmission time is, we'll see that. Before that we'll see the propagation delay. Just remember it. This is the bandwidth, okay. Now propagation delay, if you calculate, it will be definitely 500 by 2 into 10 power 8. You know the formula for that, correct? So distance by speed. You get 500 by 2, so it will be 250 into 10 power minus 8. It would be 2.5 microsecond, remember it. That means what? Propagation delay is 2.5 microsecond. Then if you double it, it will be 5 microsecond. Now if station A starts sending the first bit, it's going like this, you see, okay. Now after 2.5 microsecond almost, it is going to reach the end and it will fall away, okay, remember it. After that it will go out of the cable. But before that, suddenly B started sensing the channel and it realized that there is no signal. Just see here. So your signal is here, A signal. Now B, if it senses it, it will feel that there is no signal. Immediately lets it sending it. Then almost after propagation delay there is a collision. But that collision has to come back, right? So far at this moment when collision occurs, A cannot detect it. So the collided bit, whatever it is, that signal will have energy level more than the usual energy level. So the collided signal is now going, which is having lot of energy. Whenever it is reached at A, almost your most of the times your station A can definitely detect it. Okay, that is the general scenario. So that's why by that time also your station A should be active. Active means you should be keep on sending the data. That is what the entire story about Ethernet or CSMACD technique. Now you tell me, so how much time you should be able to send the data? 5 microseconds. That's why 2 into propagation delay plays important role. Now 5 microsecond is the answer. Now 10 Mbps bandwidth if we have, within that 5 microsecond of time, how much data we can send? We will see. 10 into 10 power 6 bits you can send per second. That is the meaning of the bandwidth. What I am doing here is I am just checking within 5 microsecond of time how much data a station can transfer maximum. It would be, we will see how to calculate it. It is 10 into 10 power 6, right? So within 5 microsecond, how much bits is the question, correct? In 1 second, 10 into 10 power 6. In 5 microsecond, how much? It is direct proportionate. You know the formula for direct proportionate, right? Reverse these two things. 5 microsecond by 1. This is 1 microsecond into 10 into 10 power 6. Correct? Here 1 second. Second will be cancelled. You get 5 into micro means 10 power minus 6 into 10 into 10 power 6. If you cancel it, 10 power 6, 10 power minus 6, you get 50 bits. So slowly you will understand that if you don't have 50 bits, then you can't, detect the collision sometimes. So that's why for safe operation, I can say that in this, especially in this LAN, the minimum frame size should be 50 bits, isn't it? So that is what the rough idea. But sir, why they kept 64 bytes? We will see. So why they kept 64 bytes? Before seeing that, first of all, you should understand one thing. So for this network or this LAN, 50 bits, right? Now, we don't know generally in the world who creates what kind of LAN and what is the maximum distance between two stations. Nobody knows, right? Now I can say that for this LAN, I would be able to say that what should be the frame size, correct? But people has to standardize it. That means, so finally world should follow some particular minimum frame size. If this kind of rule is not imposed, first of all forget about this 64. If this kind of rule is not imposed, then what happens? Anyone create any kind of data, right? Then what can happen is, so one station might send 30 bits data, correct? Then in that the operation cannot be safe. So what is the problem with 30 bits? If 30 bits is sent, then collision cannot be detected. Before that, station A will be off, correct? So that's why now you tell me, we have to standardize it, correct? So that's why, so for every network, so it is network dependent actually, correct? That's why, so to avoid the confusions, I can say that means for this network 50 bits, another network if you calculate you got 100 bits, let's say. Okay, then if you keep this one as variable, then it creates lot of confusion, correct? That's why they standardized. They said let's follow one particular minimum frame size. Okay, from now onwards everyone should know that. So Ethernet supports only 64 byte minimum frame size. No one can have a frame with less than that. But here one interesting question is, why not 50 bits? Why 64 bytes is the question, right? So if you see, if we take 50 bits with same conditions like 10 Mbps bandwidth if we take, then the propagation delay should be definitely at most 500 meters. If you have more than that, for this frame size, what happens? Let's increase the size of the Ethernet. Let's say 1 kilometer rather than 500 meters. Then the first bit takes lot of time to come back, correct? So if you use minimum frame size 50 bits, then definitely, so that 50 bits will be consumed by that station and it will go into the station, right? So it won't sense after that. But by that time, still your collision is in between. So station A cannot detect it, isn't it? So that's why, so 50 bits is not reasonable because it is restricting your LANs or Ethernets, whatever. Ethernet is a technology. So the network name is LAN. So it is restricting your LAN to 500 meters. But you don't want that, right? So generally you want to grow your LAN to 2-3 kilometers, right? And one more thing, You can't extend your LAN to 50-100 kilometers because of the medium characteristics. In your cables, the signal cannot travel to arbitrary length. Try to understand. That means a signal usually which is used in your Ethernet. So Ethernet cables are generally copper cables. Okay. So that copper cable cannot allow a signal to travel arbitrary distances like thousands of kilometers, hundreds of kilometers. It has a physical restriction. So keep that in mind. That means your LAN cannot grow more than 5-10 kilometers. Remember it. Unless there are some extra technology is used. So I'm talking about a normal copper cable. Now, so that's why what if minimum frame size is 64 bytes? Then what is the maximum cable size which is allowed? We will see. Okay, with 50 bits, what is the maximum cable size allowed? 500 meters. Otherwise, collision cannot be detected. In the same way, we will see with 64 bytes, what is the maximum cable size? Okay, let's do that. So same conditions I'm using. Bandwidth is 10 into 10 power 6 bits per second. That means 10 Mbps, and signal speed as usual 2 into 10 power 8 meters per second. So this is your leftmost system, and this is the rightmost system, and this is the maximum cable you have, which is a shared medium. Okay, so what is the maximum size we can have? We will see. But only thing is, so in the worst case we should be able to detect the collision. That is important. Example, station A is sending its frame. Okay, so what is the propagation? Let's say distance is x. Then this frame transmission time, what is the minimum frame size we are using? 64 bytes. So we assume that let's say we have only 64 bytes. So it is like this kind of story. Let's say system A is saying like this: my dear signal, you go and come back. If there is a collision, then in the worst case it will occur here. In the best case it may occur here, I can detect it. But in the worst case it will occur here, but I will know it only after 2 into propagation delay of time. But remember, I have only 64 bytes. After that I don't listen to the station or channel. So you come back before that 64 bytes transmission time. So then we will see what is the transmission time of 64 bytes. So 64 byte means 8 bits, correct? So for overall 512 bits. What is the transmission time of 512? So many times we have seen it. Frame size by propagation delay. If you calculate it, you get, frame size by bandwidth, 10 into 10 power 6 bits per second, correct? So here 512 bits. Bits will be cancelled. You get answer in seconds, correct? It would be 512 by 10, 51.2, and 10 power 6. If it goes up, it will become micro, correct? So microsecond. Now this is the answer. Propagation delay, correct? Frame transmission time, 51.2 microsecond. Now again, let's connect to the story. Station A is warning that bit signal, my dear signal, time begins within 51.2 microsecond, which is nothing but transmission time. You should come back, then only I will detect you. Otherwise I don't detect, and your entire Ethernet is false, right? So we will see within 51.2 microsecond, if that signal has to come back, then what is the maximum stretch it can take? First of all, assume that is variable x. Okay, if really the propagation delay is x, then how much distance we have to travel? The signal 2 into x. To travel 2 into x distance, what is the time will be taken by that signal? We will see. It depends on signal speed. 1 second, 2 into 10 power 8 meters. In 2x meters, to travel 2x meters, how much time? Correct? If you simplify it, you get 2x by 2 into 10 power 8. Correct? So 2 into 10 power 8. If you simplify it, you get x into 10 power minus 8 seconds. Remember it. This is the 2x time, right? That means the signal propagation time to travel 2x is x into 10 power minus 8 seconds. Now we try to relate it. Transmission time is 51.2 microsecond. Signal, if there is a x distance, then the propagation delay, otherwise I can say 2 into propagation delay is nothing but x into 10 power minus 8 seconds. So this x into 10 power minus 8 seconds should be less than or equal to that much time. Then only your station can detect it, 51.2 microsecond. So if you simplify it, x should be less than or equal to, which is nothing but your maximum cable length, right? 51.2 microsecond by 10 power minus 8. If you further simplify it, you get 51.2 into 10 power minus 8. If it comes out 10 power 8 into micro means 10 power minus 6 seconds. So it would become 51.2 into 10 square. Then that would become 5120 meters. This is the calculation. Finally, I got this distance 5120. If it is more than that, then you definitely, it will take a lot of time to come back. Meanwhile, your station will close everything and it cannot detect the error. That's why 5120 should be the maximum cable length. Then 2 into, see, this entire thing is maximum cable length, right? But generally, standard people now comes into the picture. So if this condition is not put, actually what happens, we'll see. So people may use a very long LAN with 10 kilometers, imagine, for same problem. Then what happens? Now you are very much confident. What happens if this is 10 kilometers? Then signal will go and come back. Meanwhile, transmission time will be completed and your signal will close everything, sensing everything. It cannot detect errors. That's why you tell me what should be the restriction. The cable size in Ethernet maximum should be 51. So whatever we got here, 5120, I think, right? That means 5 kilometers almost. But sometimes what happens, so the bandwidth, we are taking 10 Mbps, right? So that may not be exactly 10 Mbps. It depends on cable. Cable will have some problems. Because of that, cable creates some delays. Assume like that, okay? Signal may not travel with 2 into 10 power 8 meter second. It may go a little bit fast. Understand? That's why finally they, they cut into half, 2.5 kilometers, right? So we know that up to 5 kilometers, okay. But the standard said finally 2.5 kilometers because it considers some other stuff like signal sometimes delays some of the things, and sometimes cable will have some delays, whatever. That entire thing is physical properties. They do lot of research. Okay, we don't want to go into much details at this moment. So finally I want to say that actually it is 5 kilometers it can allow with the 64 byte frame size, but generally standard people cut it into half. And remember one thing, 2.5 kilometers is the actual restriction. So finally this frame size, minimum frame size and maximum your LAN size or maximum propagation delay, otherwise maximum cable length, they are closely connected. Understand? Now the question here, so 64 bytes is why? That means why it should be 64 bytes? Why not our 50 bits? Already we have seen that if you take 50 bits, then it allows only that 250 meter or 500 meter cable, half kilometer cable. But if you want to grow very long LAN, which grows over 2-3 kilometers, then it would be reasonable, right? 64 bytes. Typically, what people realize, how standards will come into the picture, I will tell you. They observe lot of things like, so whenever creating the standard, that committees will listen to lot of groups and they say, example, one group says that we have a LAN with 3 kilometers, 2 kilometers, 1 kilometer. Then based on that, they will put this kind of frame size. Sir, why not very big one like 15-18 bytes at a time, otherwise 200 bytes? If you take 200 bytes, then definitely, so if you take 200 bytes, then propagation delay which we allow is 10 kilometers, not a problem. Then we will be happy because you can have a LAN with 10 kilometers span. But the problem is, what if your network layer has smaller information, like who is giving us information? Network layer, correct? Network layer has data in just bytes, like 5 bytes, 10 bytes. Then to put the minimum restriction, what we are doing, did you remember? In data we were adding padding. That's why padding comes into the picture. So whenever network layer gives us 10 bytes, but let's say minimum frame size is 200 bytes, you are adding 190 bytes, isn't it? That is overhead, useless data. Then you are reducing the bandwidth. Understand? Unnecessarily dummy data you are transferring, and definitely because of that efficiency will be reduced, throughput will be reduced. Understand? That's why it should be reasonable. That's why standard people realized finally what is reasonable. 64 bytes. That is what they realized. It's not 50 bits, so that your LAN cannot grow more than half kilometer, and it should not be 200 300 bytes, so that you can have very big LAN, but unnecessarily, you are reducing the throughput, because network layer might not have that much long, data units, right? That's why finally 64 bytes is one reasonable thing for them. That's why finally standard allowed only 64 bytes. Remember one thing, I'm going to tell you standard in a detailed way now. What is standard actually? Whenever some technologies becomes popular, what happens is standards comes into the picture. Example, let's say everyone started doing computer networks. That means they started creating the networks, everything, correct? Now at that time suddenly Ethernet came into the picture. Someone proposed Ethernet technology, so that Ethernet technology, using that, so people used to send data from one computer to another computer. Okay, so that was the story about Ethernet. We have seen Ethernet uses MAC protocol to send the data, right? Everything we have seen. Now this Ethernet technology become very popular, because you can connect hundreds of systems in a cheaper way, right? There will be one common cable, and simply you need a cable, and we have to connect the computers. So it's a cheapest technology ever introduced. That's why Ethernet become popular. When Ethernet become popular, everyone started creating Ethernet technologies. Okay, so creating Ethernet technology is nothing but creating that software and hardware for that. So NIC cards. So your computer's NIC cards started supporting this Ethernet technology. Understand? Now this NIC cards vendors, who create that vendors, so they follow random rules. Sometimes some people, like example, there is no minimum frame size, then what happens? Then functionality will be disturbed, correct? That's why immediately whenever there are some popular technologies in the field, the standards comes into the picture. There are a lot of standards. One standard is IEEE. So this IEEE proposes lot of standards. Okay, so finally Ethernet is standardized by IEEE. So, and that standard is 802.3. So if there are any modifications you want to propose, then we have to convince this standard people, IEEE 802.3. Understand? Sir, what if there is no standard? Why they have to dominate these things? If there is no standard, then what happens? Everyone will create different kinds of Ethernet technologies, and there cannot be compatibility, so that interoperability will be damaged. Correct? So that's why whenever there are some popular technologies, if they are not standardized, it will be very difficult to for the people who create it and for the people who use it. That's why there should be one common standard. I will tell you one standard in India. That is example. So when you are driving your vehicle, then always you have to go left side, right? You should go left, right? You should not overtake from right side. So otherwise something, I don't remember exactly. Maybe you overtake from left or right. There is a particular rule, right? Similarly, whenever there is a light, I mean traffic light, which is a red signal, then we have to stop. Why? It's a standard. Why red? Something. So finally they said that whenever there is a red signal, we have to stop. If such rules are not created, then what happens? Everyone will, some people stop at red signal, some people stop at green signal, some people won't stop anywhere. Usually we do that, correct? So these kind of chavos will happen. That's why what I want to say is, finally every popular technology should be standardized. Similarly, Ethernet is also standardized, and whatever you have studied so far, like I said, frame, right? Ethernet frame, that is standard frame. IEEE 802.3 standard Ethernet frame we have studied. In that we have what? Destination address, source address, right? Type field, data, and CRC, everything. And CRC size 32 bits. And what is that polynomial? So there is a fixed polynomial for that. That is also standardized. Everything is standardized. Understand? Now we'll come to this point. What is maximum frame size then? Maximum frame size, why? 15, 18 bytes, I will tell you. Generally it is again, this maximum frame size is also decided by various, I can say observations. Okay, they run lot of results, otherwise lot of experiments they do, everything. Based on that they decide. But I will tell you what is the purpose of this maximum frame size, whatever it is, forget about it. Generally, so maximum frame size is used to stop the stations who try to monopolize. Example, let's say if there is no such restriction, anyone can have any length frame, then there can be some computers which will definitely monopolize. Example, let's say this is your Ethernet and these are all stations A, B, C, D. Okay. Now currently at this moment station A has data which is exactly equal to 5 lakhs bytes. Okay, very huge data. To transfer 5 lakh bytes, let's say it is taking half an hour, then all other stations will starve, right? There is a starvation problem, correct? The other stations won't get turned. For that we have to, stop the monopoly. This is called monopolization. When A is sending, others cannot send, correct? That's why we have to restrict stations by maximum frame size. A, B, C, D. Mr. Station A or B or C or D. See, maximum frame size 15.8 bytes. After sending it, then you have to stop. Then again, if you want to send, then again you sense whenever station is free, you do it. At that time, everyone is equal. Understand? But you should not do like this. Example, in the early morning, you woke up and you sensed it, you got it, then you have infinite data and you started sending since morning to night. Is that fair? No, right? That's why maximum frame size condition is imposed. Understand? So these are some of the details about minimum frame size and maximum frame size in standard Ethernet. Okay. Now we'll see one more point. Actually, Ethernet frame is standardized. We know that, right? And the new standard is 802.3. Okay. Before that also there are some other standards. Now the current standard is 802.3. So periodically, standards might be changed, depends on the people's requirements. Okay. But the current standard is 802.3. So the standard people generally they don't change, very often. So if they change something often, then what happens? All the old technologies or whatever the software, everything should be modified, right? So it will be very dangerous, and sometimes compatibility issues arises. Remember it. That's why so far whatever you have studied Ethernet frame, that is actually old standard Ethernet frame. There is no difference between old standard and new standard. That's why there is no problem. Whatever you have studied, of course, which is old one, but there is no difference between old and new with respect to frame. But the only field which has a difference is type field. Actually, in old frame, we used to have type field. Now in new Ethernet frames, the type field is modified to length field. That is the difference. But already I told you one thing. Whenever we change, some field, example type field is modified to length, right? Then all the NIC cards has to be, modified based on, this field, correct? So every NIC card now it should understand instead of type length, correct? Then we have to somehow modify either software or hardware. How we they have defined, how they built, we don't know, right? So finally you can understand that there is a lot of changes. To avoid that, what these standard people proposed is, let's allow Ethernet 2 standard and old Ethernet frame and new Ethernet frame, because only one field difference, right? Now example, let's say two computers are communicating. We don't know this device and this device. Let's say this is new device, this is old device. The only confusion arises whether the question is, when the frame is new or old, isn't it? Example, let's say this system is sending a frame. Now B has a question, is it new frame or old frame? If it is an old frame, we have to assume type as, type field as type field, correct? If it is a new frame, then that field will become length field, correct? There is a problem. That's why the standard says that whenever a frame comes, first of all, that type field will be checked. Okay, type or length field will be checked. Since we know that maximum Ethernet frame size, that means the data unit size is 1500 bytes, correct? Remember it, 1500 bytes. So if this value is 1500, more than 1500, approximately 1500 bytes, let's say, whatever, try to understand the logic. If this value is more than 1500, then definitely that is not length, then it should be type. In that way, we can easily detect whether it is old frame or new frame. That's why now still people are using old frames and new frames. That means still old NIC cards and new NIC cards are compatibly working. Understand? Now there is no problem with old frames and new frames. That is one point you should understand. So easily we can differentiate based on this value. So this type or length field value is more than 1500. Definitely we can't have such data. That means it's supposed to be type field. In that way, so we can say that this is old frame. If this is something 200 or 300, then easily, I mean, definitely we can say that it is a length field. In that way, we separate Ethernet 2 frames and Ethernet frames. Okay, apart from that, there is no difference. Generally, one more thing you remember, thumb rule. So, this Ethernet frames structure cannot be easily changed. One more thing I am going to tell you. What is the minimum frame size? 64 bytes, right? I am going to teach one point where, so far you know that Ethernet follows CSMA CD technique for multiple access control, right? We know that. But this entire thing is old story. So nowadays, there is no collision in Ethernet. How, sir? I am going to teach you one technology, otherwise I can say one arrangement where all the computers are connected through switch. Just remember one point. That is called switched Ethernet. So in switched Ethernet, there is no collision. So this entire minimum frame size, everything is defined based on that concept of collisions, right? To detect the collisions, we kept 64 byte minimum condition. But if we change this minimum condition, and if the standard, let's say, assume that says that from now onwards we are not getting the collisions, so no minimum frame condition is required, and if standard changes that, then everything will be collapsed, right? Now all the NIC cards has to be modified, so a lot of drivers has to be changed. Since Ethernet is such a popular technology, then we should not change it very often, understand? So that's why frame structure will not be modified. If frame structure is modified, lot of damage will take place with respect to money and all, correct? So remember one thing, so it is not so often that Ethernet frame will be modified, understand? Remember, now in Ethernet frame we will see destination address and various kinds of destination addresses. Whenever a frame contains a destination address which is 48 bit, so that can be that can be separated into 6 parts: byte 1, byte 2, byte 3, so on, byte 6. So in byte number 1 there will be 8 bits, correct? Let's say bit 1, bit 2, bit 3, in that way. So there are 8 bits. This is least significant bit and this is most significant bit. Okay, now based on the least significant bit on the byte number 1, so these various kinds of addresses are defined. Example, let's say you have one destination address, and how receiver is going to understand it, we will see. If the destination address, that LSB bit we are talking about, especially in byte number 1, if that is 0, then that is called unicast address. What is unicast address? What is multicast address? What is broadcast address? I will tell you. Whenever, see, when two computers communicate, so these three kinds of cases arise. One is, this station A wants to send exactly to one particular station. A wants to talk to only one particular station. Especially now we are in Ethernet. That means, our medium is common medium. Now everyone will receive the messages, remember it. Okay. So physically talking, that means with respect to physical topology, I can say that this is called a broadcast network. Okay. Network is broadcast network. Now we'll see some details about destination address. This destination address can be used for various kinds of communication, and we'll see what kind of communications are possible. Generally the communication can be unicast, otherwise multicast or broadcast. We'll see one by one. Example, in your LAN, so these are all various computers, and we know that it's medium is shared, correct? Multiple computers are using the same medium. So now station A wants to send a message to only station B. That means only B should read it. Okay, that kind of communication is called unicast communication. Now sometimes, so maybe A wants to send a message especially for a group like CDE. That message should be forwarded to E, C, D, otherwise it should be reached to E, C, D. Such kind of communication mode is called multicast communication. Third mode is sending to everyone. That means that message should be received to everyone. So that is called broadcast message. Okay. Now we can implement unicast, multicast, broadcast in your Ethernet. Though your system, you see here in the physical level, it is a broadcast system, correct? That means by default your physical topology supports broadcast system, right? That means if you don't carefully plan, every system can read that message because medium is common. But of course, because of our protocols and our I can say because of our protocol, we can implement unicast, multicast, broadcast. Okay. So for that, your destination address is going to help us. How destination address is going to help in C? So your destination address has 48 bits or 6 byte, right? So byte 1, byte 2, so on, byte 6. So in byte number 1, if this bit is 0, then that address is called unicast address. That means, such kind of messages whose destination address, in that LSB bit here is 0, that is going to denote unicast communication. Now if we write multicast, that means if you want to have multicast communication, this bit is supposed to be 1. Such a way we have to write. Now, if you want to have broadcast messages, for that we have to change the destination address pattern. For that, and one more thing, it's a special case of unicast, correct? What is unicast? Sending a message to a particular group. What is broadcast? Sending to everyone. So that's why sending everyone is a special case of multicast. That's why this bit is 1 for broadcast also. But what is the difference between unicast and multicast is broadcast and multicast is, in broadcast every bit is 1. So this pattern is given for broadcasters. Now let's summarize. So if this bit is 0, then it is going to be unicast. If this bit is 1, but not all are 1s, that is multicast. And if everything is 1, that is going to be broadcast. In that way, we can differentiate all the communication modes. Understand? Now we'll take some 3 addresses and we will see whether they belongs to unicast or multicast or broadcast. Okay. Consider these destination addresses. Now we will see whether they are unicast, multicast or broadcast. We start with 4A. This is hexadecimal notation. Okay. So each bit or each digit represents 4 binary bits. Okay. So 4 means 0, 1, 0, 0. We know that we have to focus on this position, right? Now see 4A. 4 means 0, 1, 0, 0. And A can be represented. What is A value? A represents 10, binary 10. So what is binary 10? It would be 1010. So this is going to be the first byte pattern. In that you have to see the least significant digit, which is 0, right? That's why this is unicast. Now it is going to be an address of one particular receiver. Now 4720 in that 7, right? So we have to focus on 7. So directly 7 is 0111. So now this bit is 1, means it is either multicast or broadcast, but not all bits are 1s, right? That's why it is multicast but not broadcast. Multicast but not broadcast. Now here you see this one. So 1111. It means, so this is multicast, but we don't know whether it is broadcast or not. For that, if you want to know whether it is broadcast or not, every bit should be checked. Since here everything is 1, you see 32 ones, so it is broadcast. Of course, there is only one broadcast pattern, that is all ones. Easily we can detect F. If you have everything as F, then that is going to be broadcast address. Okay, so this is a way we can easily detect.